All right, here we go. Consider the modified Atwood machine below. Block 1 is released from rest and slides a distance d along the frictionless table. Oh, thank you. That's helpful. Block 1 is connected to block 2 by a massless, inextensible string. That means it's easy, which falls under the influence of gravity and the tension force. Okay, terrific. Okay, find the final speed v of block 2 in terms of m1, m2, d, and any relevant constants. Okay, I don't know what this is doing there. Okay, all right. Okay, well, let's see. I don't really know, but again, surprise, just do the same thing you always do. Doesn't matter. 1 and 2. I'm going to say that way is positive. Make sure you mark that on your picture. Okay, so 1 is going to have the tension. I'm just going to label this. Well, I'll just label it FG. FG, FN, those are equal. Okay, block 2, going to have FG2. Okay, and FT, that has to be smaller, right, because we know it's going to accelerate. Okay, and those are equal. Oh, I did that last time too, okay. All right, okay, and I'm looking to find the speed of block 2. So really what I'm looking to find is the acceleration, okay? So everything they ask, whatever, you really just want to find the acceleration, okay? So let's see. I'm pretty sure we can do this kinematically. Let's see. All right. Let's see. Okay, so sum of the forces equals MA. Let's just do both of these. All right, I've never done this problem before, so see, I'm sort of like just going to work it out, right? So don't get panicked, just do something, right? And it'll probably come out. Okay, this is nice and convenient, right? Because that's just going to come out with no friction. That was helpful. Okay, and this one, FG2 minus FT equals MA. Okay. All right, and then let's try to get an expression for the acceleration. I don't know where the D's coming in, but let's see how this goes. All right, so FG2, I'm just going to write M2G minus, okay, can you see this is exactly the same problem as last time? Like, it's always the same. Okay, and that's a 2. That's a 2. That's a 1. Okay. All right, so let me add this to the other side. M2A plus M1A. All right, and then I'll factor out the A, M1 plus M2. Okay, so acceleration equals M2G over M1 plus M2. Is that all stuff we're allowed to have? Because if so, who cares about the D? Maybe that was for some other part of the problem. Oh, find the speed. Oh, there we go. That's the problem. Never mind. Okay. All right. So that's the acceleration. So that's all acceptable things, right? M1, M2, and any relevant constants would be G. Okay. So that's good. All right. Now I want the speed of block 2. All right. So I'm looking at the hanging block. Okay. Initial velocity is 0. The acceleration is whatever the heck this is. Okay. I want to know the final speed. Okay, and the distance, or, well, let me say the delta x, they called the variable d, okay? So look, if this one moves d, this one moves d. They're connected. It has to be the same for both. Okay, so then hopefully you will recognize I want to use this one. Okay, that's going to go away. Thank you. That's helpful. Radical 2a delta x. Radical 2 m2g over m1 plus m2 times d. Okay, and then I guess that's as nice as it gets. 2d g m2. I don't know, it doesn't matter what order you write it in. I thought that was better, but not really. Okay, right? So I have m1, m2, d, and g is a constant, so that's fine. Okay, right? So the process is the same every time. Does not matter what you're solving for. You're going to have to solve the force diagrams and get A. You're almost always going to have to simultaneously solve like this for the tension. Okay, plug it in however you want to do it. It's up to you. Okay, and then if they ask for the tension, then I'd have to go back to this, but they didn't ask for that. All right, that wasn't as bad as I thought.